In this lesson, we're going to be looking at the insertion sort algorithm. So insertion sort works by constantly sorting the front of the array. It's going to compare index 1 to index 0, and if index 1 is less than what's in index 0, it's going to swap them. This means index 0 and 1 are now sorted in relationship to each other. It's going to then move on to the next index, index 2, and sort it in relationship to index 0, 1, and 2. And so the front of the array is constantly going to be sorted. So 0, 1, 2, when we sort in relationship to each other, and then 0, 1, 2, 3, 0, 1, 2, 3, 4, 4, and so forth. So here's the method for the insertion sort. So it's going to traverse the whole of the array. And it's going to get this key here. This key is the element it's going to pull out of the array. And it's going to determine where it belongs in relationship to the front of the array. And then this for loop here is going to traverse the front of the array, going backwards, finding where the key belongs. And it's going to shift everything over to make sure it's going to find the correct place for the key. So these elements are going to shift over. So if we got like 1, 5, 8, and we got to input 2, it's going to pull the 2 out into the key. It's then going to shift everything over. So the 8's going to be shifted over. Here's the 8. So you now have got 2 8s. It's going to then shift over the 5. So you got 2 5s. It's going to be, then it's going to it's going to compare the 1 and 2 and be like, okay, 2 goes before the 1. So it's going to, the 5 here is erased, and then the 2, which is the key, is inserted. So the front of our array is going to constantly sort it. So if I then put another element, like let's say 3, 8's going to shift over, 5's going to shift over, and then it's going to input the 3 there. Okay, so big O notation. Big O notation is used to classify algorithms by how fast they are able to work based on an input size. So given a collection of size n, the insertion sort, its efficiency changes based on how well sorted the array already is. So random order, it's approximately O of n squared. But best case, something that's already sorted, it doesn't have to do anything. It just pulls out the element, sees that it's actually already in the correct place, and puts it back in. So it's extremely fast on something that's already sorted. The worst case scenario, which is the array is in reverse order, it's going to take O of n squared. So it's extremely inefficient in worst case. So let's actually see how insertion sort works here. So remember, it's going to keep the array sorted in relationship to itself. So what we're going to do is we're going to just go through. So the first 2 elements, they're already sorted. Then I add the 3. So it's going to end up being 3, 4, 8. We add the 5. 3, 4, 5, 8. We add the 1. 1, 3, 4, 5, 8. We add the 9. 1, 3, 4, 5, 8. 9. We add the 6. 1, 3, 4, 5, 6, 8, 9. We add the 7. 1, 3, 4, 5, 6, 7, 8, 9. So again, you can see the elements are remaining sorted within relationship to each other. Now, if we wanted to do it, more thoroughly, showing all the swaps and whatnot, it's going to be much, much larger. So 4 and 8 are already sorted. We added 3. So what happens is the 8 shifts over, the 4 shifts over, and then the 3's input. Then let's do the 5. So the 8 shifts over, and then the 5's inserted. So you can see if I'm showing every single swap, it's a lot more going on. But that's the idea of how the insertion sort method works. And that's the end of this video.